Here is your inequality solving part 1 video. So we'll skip over number 1 and number 2 because I'd really like for you to come up with those answers on your own, and we'll focus on number 3 here. So it says solve the following inequalities and represent their solutions on a number line. But before we begin, I just want to sort of recap what we started to do last week in class. Remember, we started with 4 is less than 6. And we talked about whether or not this was true, and we said this was true. On a number line, 4 is further to the left than 6 is. We also know that 4 is indeed less than 6. We then said, what happens if I take 4 and I add 3 to it, and I take 6 and I add 3 to it? Is this inequality still true? Can I add the same number to both sides and still have a true inequality? And we ended up getting 7 is less than 9, which is true. So I know that I can add the same number to both sides of the inequality and it still holds true. We then took that same 4 is less than 6 and we subtracted 3 from both sides. And we said, is this still true when we subtract the same number from both sides? We ended up getting that 1 is less than 3, and this is also true. So as we go forward and we solve these problems, I know that I am not really breaking any math rules and that I can add and subtract the same number to both sides of an inequality. So that's just a little recap of sort of where some of this is coming from. So to solve an equation, remember it means that we're getting the variable alone on one side all by itself. What does x equal? To solve an inequality, we're doing the same. We're getting the variable alone on one side of the inequality symbol. So x plus 3 is less than 5. I can subtract 3 from both sides and get that x is less than 2. And to graph this on a number line, this is a less than and not less than or equal to. So I know that at 2, I can have an open circle and I can shade all of the x values that are less than 2. So looking in this direction over here. Looking at part B, I can add 6 to both sides to get x alone. So x is less than 11. Again, I can go ahead and make my number line. Here's my 0. Here's 11. Let's call this negative 5. Again, I'll have an open circle and x is less than 11. So these are all of the values that are less than 11 in this direction. Looking here at this next problem, 2x plus 3 is greater than or equal to 5. I can do this the same way as if I were solving an equation. So subtract 3 from both sides. 2x is greater than or equal to 2. Divide both sides by 2. And I end up getting that x is greater than or equal to 1. So creating my number line here, I have 0, 1, let's call that negative 1. I know that I'll have a closed circle at 1, and all of the values that are larger than 1 are represented on the right side of that inequality. So I'll let you go through. This is just sort of to get you started here. Again, this is part 1 of our inequalities. I'll let you work through the rest of these problems. There's some word problems that are on the back for you. Please let me know if you have any questions.